Welcome to week 4 of construction print reading. This week we will look at plans dealing with site utilities and improvements. Previously we looked at surveys and site plans dealing primarily with laying out the property and grading in preparation for further construction. While we did not cover these kinds of plans, included in that category might be clearing and grubbing plans. That is, plans showing areas where trees would be removed and stumps would be taken out. As a project, we are following the sequence of plans. So this would be the next step. We would want any underground utilities to be installed before we start building the foundations, so it would not be necessary to cut through a brand new foundation in order to install utilities. First, let's cover some definitions. An invert. An invert refers to the bottom of a pipe or a basin or a culvert. We will have elevations for inverts in and out of pipes, but those elevations will be the inside pipe wall, not the bottom of the pipe. If we're talking about a structure, such as a manhole or an inlet, the invert elevation is the bottom of the inside of the structure, not the excavation depth. The rim, on the other hand, is the top of a manhole or a catch basin or any such item that might be installed. It is normally used for stormwater or sanitary purposes, and the elevation is the top of the cover of a manhole or an inlet grate. And if it is installed in a roadway, that elevation is usually considered to be final grade. So let's start with the Wendy's C4 utility plan. And we're going to look at this section of the plan first. This plan shows the routing of the storm and sanitary pipes and the various elevations for rim and invert. Looking at it a little more closely, you can see that we are showing the type, storm, sanitary, 122 feet, approximately 12-inch RCP Class 4. That would be reinforced concrete pipe Class 4 at 0.5%. We're talking a grade from this point to this point. This pipe would descend, change elevation, 0.5% or 1/2 foot in 100 feet. And we can check that. Since this is listed as being 122 feet, at 5.5% or 1/2% grade, the change in elevation from this point to this point would be 0.61 feet. If we look at the invert elevation for this inlet, it is 770.48 feet. The inlet or the invert elevation for this structure is 769.87. The difference between this elevation and this elevation is 0.61 feet. The grade that is being shown here. Let's look at some of these in more detail. Note that we have the rim elevation and the invert elevation. That is saying that in this particular catch basin, CB, catch basin number 3, the invert is about 3.6 feet below the rim. Here is an inlet, and you can see a rim elevation and an invert elevation, and this tells you it is a storm sewer. Notice we have here copper water service, and here is the line with the W, telling you that this is a water line. Here we see more storm and sanitary sewers. Again, notice this sanitary is in light print, sort of dashed line, but more light print as opposed to bold print. This is an existing sanitary sewer, and we are connecting to it at this location. I'd like to draw your attention to this manhole here in the sanitary. Notice it has invert elevations EN and invert elevation W. These are compass headings. This has a similar compass of multiple invert elevations, as does this grease trap. Remember our north arrow. That says that this is north, this is south, this is east, this is west. So if we look at this grease trap, it tells me that the north invert is the entry point. The west invert elevation is the exit point. And you can see that the entry is a little higher than the exit. This particular manhole has inflow from the east and from the north, and an exit to the west. This particular manhole has an entry coming from the east with an elevation. The exit, notice the plus or minus, it says match existing. There is an existing storm sewer here, and whatever elevation the exit is what we want this to match. And the whole idea is that water is flowing downhill, and so we want to make sure that our entries are higher than our exits. The profile for this proposed sanitary sewer, I want to draw your attention to the fact that there are two different scales. 1 inch equals 20 feet horizontal. 1 inch equals 2 feet vertical. So 0 plus 0 is what is called survey stationing. This represents hundreds, this represents feet. So this is the beginning at 0, 0. 1 plus 0, 0 means 100 feet. And 20 feet, 40 feet, 60 feet, 80 feet, 100 feet. Horizontally, 1 inch equals 20 feet. Now, vertically, it's every 2 feet. So, 2 feet, 2 feet, 2 feet, 2 feet, 2 feet. Notice that we only change elevation by 10 feet here. If we had a 1 inch equals 20 scale, all of this would be shown in just half the distance. On the other hand, if I used 1 inch equals 2 feet for the horizontal distance, it would give me a drawing that was 50 inches long. So when you get profile drawings, they will always look a little odd. It'll look very, very steep because I have a one scale for vertical and a bigger scale for horizontal. Notice there's an existing 12-inch water main shown here, and it interferes with the sanitary pipe. So they are relocating this proposed water main. Let's look at drawing C2 for Wendy's. This is sort of a site improvement plan. It shows the geometry of curbs, sidewalks, and the parking lot. Notice I have dimensions front to back, back to property line, back to front. So there are parts of the curb, they are measured to the front, to the back. And I show this because there is sometimes a tendency to use as few drawings as possible. In my opinion, if you were to design this, I'd take these locations, and with AutoCAD it is much simpler to do. You simply go to a larger scale and show these in detail, and you don't have to do front to back. You can show exactly where you are measuring to. And the same goes for down here, 10 foot back to back of the curb. Is there a detail that tells me what the back of the curb is? Where's the front of the curb? What am I measuring to? I believe it's confusing and can be better shown. Do want to show once again the stylized north arrow and the graphic scale. What's important about this is we are being drawn to a scale of 1 inch equals 20 feet. Sometimes you may not be in the field with a scale, or you are given a copy of the drawing and it is not the proper scale. You can take this, take a piece of paper and measure, put a mark here on your paper, a mark here, and a mark here, and you can then use it for a rough estimate of distances because you now have created a scale. 0 to 10. Any mark, I could take these two marks on a piece of paper and come over here and they will match. This will always be in scale with the rest of the drawing. It may not exactly be 1 inch equals 20 feet, but you can use this as a match. This drawing also includes some notes, and I just wanted to point those out. It says reference IDOT standard specifications. This could be any state that starts with an I, but if you do a quick Google search, IDOT turns up Illinois DOT. Might be Iowa, might be Indiana. You would have to know where you're building this. Notice it says latest edition. One thing to keep in mind, these types of standard specifications will change. And by saying the latest edition, you know you are always using the latest and greatest. But keep in mind that you were looking at the 2013 edition of Section 406. The 2017 edition, which is the latest one available, may have changed Section 406. And so you may not be specifying the same thing. So this is a good way to write it, but always make sure that what you are specifying is accurate. Notice they talking about a 6-bag mix. Notice it says PCC. That stands for Portland Cement Concrete. Now, 6-bag mix technically means concrete mix that has 6 bags of Portland cement in it. It's an old style way of describing it, but 6 bags of Portland cement and how much aggregate and how much water, because of advancements in concrete design, how many bags is no longer a practical way to identify the concrete strength. A lot of concrete mixes now have additives to them. They are designed for a specific compressive strength. If you go on to take CNST 2131, we will talk about something called water-cement ratio. There's a certain amount of water that should be applied to a certain amount of Portland cement to get a proper mix. Adding more water might make the concrete easier to work with, but will reduce the strength of the concrete. So 6-bag mix is usually about a 4,000 psi concrete. Notice here it talks about the subgrade being compacted to not less than 95% of the standard laboratory density. Section 301, probably referencing IDOT, explains about laboratory density. Basically, a sample of the earth at this site is sent to the laboratory and compacted. And when we're in the field, we want to compact it and get at least 95% of the results we got in the laboratory. And that's what they're talking about here. And finally, the last piece of information I want to talk about on this sheet is this on-site parking data. Notice parking required 20 spaces per 1,000 square feet. Floor area, 85% of the building area, and so parking required is 57 spaces. This is a code requirement. We talked about codes. So how much parking spaces are required has to do with how many 1,000 square feet of floor area there is. Now, can they put in more than 57 spaces? Absolutely. You just can't put in. Notice here it says regular spaces 41, handicap 2, total spaces provided 43. So they may have required 57 spaces, but they're only putting in 43. Question to bring up and see how that is going to be handled. Let's take a look at Shaw Place, sheet A1.1. This is also known as the multifamily dwelling. A close-up view. Notice we have 4 20-inch oak trees to remain, 3 10-inch pines to remain. We have some concrete retaining walls, planting area, PVC storm sewer, a 6-inch PVC storm sewer, a 4-inch PVC storm sewer, and these are callouts. Remember we talked about leaders. This leader tells you that this is the 4-inch PVC storm sewer, and up here. Notice we have here UE transformer. If you go further down in this document, there isn't an abbreviation for UE. However, we do show new underground electric service, notice the E, coming from this pad that says transformer. So using a little common sense, we can assume that this means underground electric. Up here we have foundation iron pipe. Normally a survey will put a pipe or a stake or something in the ground so that this corner can be found. Now, a couple of things that you need to be aware of, because sometimes people will make mistakes. It says here foundation iron pipe. Well, FND is not in the list of abbreviations. IP for iron pipe is, but here they've spelled it out. So you have to watch that. Down here it says FNE cross. Well, again, there's no abbreviation for FNE, but common sense would suggest that maybe they're talking about FND or found. That's another thing it could be. Found iron pipe. Here is, could this have been found cross? In other words, this was an existing property line and somebody went out and resurveyed it and found an iron pipe. So notice the abbreviations here. We do not have anything for found. UE, UG is underground, and that calls it UE for maybe underground electric. Not quite clear. If you are the contractor, you want to ask the question of your designer. Looking at the bottom half, notice we have, blowing this up, here's our north arrow, our graphic scale. Notice this notation, plan north. That's to avoid having to call this side of the building the northwest side. By using the plan north, this becomes the north side, this becomes the west side. Here's my property line. It's a curved property line. Radius equals 870 feet. Length equals 229.75 feet. I believe we've talked about that already. More trees to remain. 3 gums and 1 maple. We have an abbreviation here, DS, which if we look up in the list of abbreviations, we find this is a downspout. G for a gas line. We have PL for property line. We have a contour of 575 feet. And we have a site plan scale of 1 inch equals 10 feet 0 inches. Now, the 0 inches is not necessary. 1 inch equals 10 feet, but we would use a engineer scale, a number 10 engineer scale, if we were going to do rough measurements off of this drawing. And that ends week 4.